All right, let's get right into it. Today, we're talking about what really separates a cool demo from a system that can actually run in production without falling over. We're moving way past basic prompting to master the three core architectural patterns that matter: React, reflection, and planning.
Does this feel a little too familiar? You've been there, right? You build this amazing agent, it works perfectly on your machine, you push it to production, and bam, it crashes. Again. Maybe it got stuck in a loop, or a tool gave it some weird output it couldn't handle. It is so frustrating. And look, this isn't a junior dev problem. This happens to everyone.
So why does this keep happening? Well, your first instinct is probably to blame the model, right? To think, oh, if only I had GPT-5, or I just need a bigger context window. But here's the secret. It's not the LLM. It's the architecture. The most robust, stable agents aren't just running on bigger models. They're built on smarter designs. Success comes down to how the agent thinks, acts, and learns.
So here's our game plan. First, we'll nail down the core problem with agent architecture. Then we'll get into the good stuff, the three big patterns: React, reflection, and planning. And to wrap it all up, we'll look at how these are used in the real world and the trade-offs you absolutely need to know about.
Okay, first up, why do we even need these fancy patterns? Well, think about a standard prompt you send to an LLM. It's a one-shot deal. You fire and you forget. That's kind of like telling a developer, hey, build me this entire application, but then locking them in a room with no internet, no way to test their code, and zero feedback. It's just not going to work for anything remotely complex. It doesn't scale.
And that's exactly where these design patterns come into play. If you're from a software engineering background, this should click immediately. Think of them just like the classic Gang of Four patterns, singleton, factory, observer, but for AI agents. They're these battle-tested, reusable blueprints that give our agents a solid structure for reasoning, using tools, and, most importantly, learning from their own mistakes.
Let's start with the absolute foundation. And honestly, this is the workhorse for maybe 80% of what you'll build: React. The whole idea here is to create a super tight feedback loop between thinking and doing. It grounds the agent's reasoning in the cold, hard facts of what happens when it actually tries something.
The beauty of it is just how simple and powerful it is. It works like this. First, the agent has a thought, like, okay, I need to find the population of Paris. Then it takes an action. It calls a search API tool. Then comes the observation. It gets the result back. And here's the key. That observation feeds right back into the next thought, and the whole loop starts again. Thought, action, observation. Over and over until the job is done.
And this isn't just a nice theory. The numbers back it up big time. On the HotpotQA benchmark, a baseline agent that just acts without thinking gets an accuracy below 30%. But the moment you add that React loop, accuracy jumps to nearly 48%. That is a massive performance gain, and it's purely from an architectural change, not a bigger model.
So what does this look like in code? Well, using a framework, it's pretty straightforward. You'll have an agent executor that wires everything up. But I want you to focus on one thing here, that max_iterations parameter. This is non-negotiable for production. Trust me. You do not want an agent going into an infinite loop. I've personally seen simple agents rack up hundreds of dollars in costs overnight because they got stuck. This one line is your most basic safety net. Please use it.
Okay, so React is great for getting things done. It's our workhorse. But what if done isn't good enough? What if you need it to be correct? That's where our next pattern, reflection, comes in. Think of this as the quality control upgrade for your agent. It's how you build agents that can critique their own work and get better, all without any model retraining. The architecture here is really quite elegant. You have an actor LLM that generates a solution, say a block of Python code. Then a separate evaluator assesses it. Does it run? Does it pass the tests? If it fails, and here's the magic part, a self-reflection step kicks in. The agent verbalizes why it failed, generating a thought like, I made an off-by-one error in the loop. That reflection then gets stored in memory to inform the actor's next attempt.
And the results are just stunning. On the HumanEval coding benchmark, a standard GPT-4 gets about 80% of problems right on the first try. But an agent using this reflection pattern hits 91%. Now just think about that. By adding a structured process for self-critique, the agent actually surpasses the raw capability of the powerful model it's built on.
So React is for doing, reflection is for quality. But what about tasks that are so complex they require a real strategy before you even start? For that, we need our third pattern, planning. This is all about decomposing a large goal into an explicit, step-by-step plan before executing a single action.
And the difference this makes is just night and day. Take the game of 24, a reasoning puzzle that's notoriously hard for LLMs. With a standard prompt, GPT-4 solves it only 4% of the time. Pretty bad. But an agent using a planning method called Tree of Thoughts achieves a 74% success rate. That isn't just an improvement, it's a total game changer for complex reasoning.
So this gives us, the engineers, a very clear trade-off. React is faster and cheaper, perfect for interactive tasks where you need a quick response. Plan and Execute, on the other hand, has higher latency and costs more API calls because of all that upfront thinking. But the payoff is significantly higher accuracy on complex jobs. We're talking 92% task success versus React's 85%. You got to pick the right tool for the job.
Now for the most important part, how does this all come together in the real world? Because in production systems, you're rarely going to use just one of these patterns in isolation. The true power comes from intelligently combining them and managing the very real trade-offs of cost, latency, and accuracy.
Let's look at some examples you probably use every day. GitHub Copilot's chat, that's basically a React loop interacting with your codebase. Perplexity AI, that's a multi-agent system where different React agents handle searching, synthesizing, and verifying. And Claude's coding tools, that's a beautiful combination of reflection and planning, forcing a strategic plan, and then self-critiquing the result.
You know, this table is something every AI engineer should probably print out and tape to their monitor. It shows the stark reality of these patterns. As you move up the ladder from a simple prompt to full plan and execute, your latency can increase tenfold, and your cost per query can jump from 2 cents to nearly 20. Choosing the right architecture isn't just a technical decision, it's a critical business decision.
And these are the dragons you will absolutely face in production. Your agent will get stuck in a loop. A tool will return an unexpected error and crash the whole process. Your costs will balloon if you use a planning agent for a simple query. And yes, you'll have to defend against prompt injection. These aren't theoretical problems. They are the day-to-day reality of building these systems.
So here is your implementation roadmap. 1. Start simple with React and just a couple of tools. 2. From day one, build in observability and safeguards like those iteration limits. 3. Layer in reflection, but only for your quality-critical tasks like code generation. 4. Use planning sparingly, just for your most complex workflows. And then, the final, most advanced step, build a router that sends each request to the most cost-effective pattern for the job.
So, we've moved beyond the black box of the LLM. We've seen that the true power to build robust, reliable, and intelligent systems lies in the architecture we choose. React for action, reflection for quality, and planning for complexity. These are the blueprints. The only question left is, what will you build with them?